We were talking about ocean crust where it comes together, converges, and one side we said would subduct or go underneath. The other would also be pulled down a little bit to form a deep trench. Okay, as this subducted zone goes lower and lower, it begins to melt partially, and magma rises, could causing volcanic eruptions. If they're big enough, the eruptions might form volcanoes that are big enough to stick out the top, such as the Hawaiian Islands and a lot of other islands, Japan, the Aleutian Islands, which are up by Alaska. And over time, this hotspot moves, as the crust moves, sometimes you will see what we call an island arc, which means like in the Aleutian Islands you have Alaska roughly here, okay, and then there's this string of islands, and what we kind of think is that there's one of these hot spots where you have melting stuff happening here and coming up, but as the plate moves and it's moved over and it blew up, made this island, and over time it moved over and blew up again, made another island, and since the plate is moving, you've got this string of islands, and you'll see this a lot even in the Hawaiian Islands and like I said, Japan and some other islands out in the Pacific especially. You will see these string of islands, and it's because we think as the plate moved, then these hot spots where it bubbled up from the magma underneath formed these island arcs. Arc, we just mean A-R-C, like a curved line. So there's a curved string of these islands forming in an area like this, and that's why we think that happens. So that would be ocean to ocean convergence. Okay, if you have two oceanic crust, one will go underneath the other and subduct, and then you get this kind of dynamic. The second type we'd like to consider, if you have oceanic crust, like over here, and it is running into a continental crust. Okay, this is very common also, especially on the western edge of the United States, the western edge of South America as well. And basically here you have the ocean crust coming in. Now since it's heavier and denser, it tends to be subducted underneath the continent. Okay, because the continent is thicker and less dense, so it kind of floats higher, and so the subduction goes underneath it. Once again, you have a trench. In this case, it's a trench. The ocean-to-ocean one, you may have one way out here in the middle of the ocean. Okay, these are close to shore, which is kind of odd because people think, oh, it's shallow as you go to the continent, and then it just gets deeper and deeper and deeper, and that's not necessarily the case. In this case, many of these trenches then are formed right up next to the very close to the continents. Okay, and so as this oceanic gets crust, once again it gets deeper and deeper. There's partial melting, and some of this magma may balloon up, and very often you have strings of mountains running up and down the coast of the continent that are formed from volcanoes. Okay, the Cascades, and I'm thinking it's the Sierra Madres in California and so forth. There's a whole range of mountains along the western coast, and they're formed by this. Now, in the United States, North America, those volcanoes have not been very active. However, an exception to that, of course, would be in the 70s. I would say around 1970, maybe 74. But anyway, Mount St. Helens blew up and blew off about half the mountaintop. Okay, so that's these kind of volcanoes that are formed by this magma forming underneath, and if it comes up, they can become active. All right, and so the oceanic goes underneath it, and because it's more dense, you get some melting, so you get the magma that comes up, and in the South America you have the Andes Mountains, which are also on the west coast basically of South America and so forth. You could consider this kind of like the island arc we saw, maybe a continental arc, if you will, but basically these are just all connected, and since they're all if you were in the ocean, you would only see the tops of the very tallest ones perhaps sticking above the ocean, but here, since it's all above ground, you see the whole mountain range. So it's kind of basically the same phenomenon happening, just difference between underwater versus above water. Now, with the ocean going on the continental, you could also have some earthquake involved with that, but you have a lot more volcanic activity. Now, the last one we're going to talk about is continental to continental convergent crust. Okay, so you have continental crust that's coming and running into more continental crust. Well, we know both of these are going to be light, and they're also going to be thicker, and so basically what happens is one continental crust is subducted and goes underneath, but it's so thick that it doesn't build up the pressure that it might have otherwise. And so you don't have as much melting and you don't have as much volcanic activity because it's farther down to get to the magma because you have a thicker crust on the continents. And neither one of them really wants to go down very much because they're both fairly dense and they want to float up on the top. And so basically you have a collision between two continents, and since they don't want to budge a whole lot, instead of subducting and getting a lot of volcano activity, you tend to just get this bunching up, okay, of the crust, okay. And as these push together, you might have some earthquake activity and stuff, but mostly you just bunch up and mountains get pushed taller and taller. In the Himalayas and Mount Everest and some of the very tallest mountains, Alps in Europe, the Appalachian Mountains on the east coast of the United States, were thought to have formed maybe where two continental crusts run into each other, and so it kind of buckles up, okay, it gets thicker and buckles up where it's coming together, puts pressure, it rises this middle part, and you end up with mountain ranges here, okay. Here, you, like I said, you might get earthquakes or something like that, but you're not going to get so much, you don't get very much volcanic, if any, volcanic activity, and that's kind of different from the other ones. When you have oceanic crust down here, it tends to melt and create volcanic mountain ranges. All right, and that's really about it for the plate tectonics. Like I said, it was an idea that some of the ideas for it came along fairly early. The continents fitting together in the 1950s. Alfred Wegener. During World War II, a lot of the proof for it came from sonars and submarines and stuff that were out in the ocean as they were learning more about the shape of the Earth's surface. Incidentally, while they were looking for submarines and things of that sort. And so yeah, but eventually it explained a lot of the phenomena that people saw with earthquakes and volcanoes and how all that worked together and kind of fit together. And it took a while, like I said, to explain, because we still can't see the inside of the Earth, but we can start getting more and more evidence, and that's why we believe in the convection currents that move around the continents. At first, that seems just like an outrageous idea, but it can be done. And we have tested, I think I said this earlier, but we have shot back lasers now that we have precise measuring systems either on Earth. We can have laser stations set across on each side of the fault, and we can measure how much some of these faults are actually moving and how much these plates are actually moving. And the moon has some things that they can shoot back and see, but and we can see that they actually are moving, but once again we're talking inches per year, very small amounts. It would take many years for it to be noticeably different, okay. And so who knows where they'll all be. You will see different maps of where the continents were at different times, and once again, as we go back in the past where the continents used to be exactly, there's going to be some leeway there, okay? We don't know as much. We're pretty confident about what's happening now, but we can't, as you go back in time, what are they going to look like in the future, what the continents look like? You can find drawings of people saying where they think the continents will be down the line in the future, but once again, it's kind of hard to predict that stuff. We're doing pretty good at explaining what's happening now, but predicting what it used to be and what it will be in the future is kind of like predicting what climate change. There will be climate change, but we just don't know exactly what it will look like. All right, and that's it for plate tectonics.